Okay, we will continue with multiple regression analysis, uh, analysis of relation between one dependent, one interval dependent variable, and more than one uh, independent variables. Here in our data set, we have only one additional interval variable, and this is if yes, how many cigarettes do you smoke per week? Because before that, the question is, do you smoke? With two answers, yes or no. And if one person is answered yes, the next question is how many cigarettes per week. But if one person is answered no, then here in this variable is entered 0. So if one person smokes, then we know how many cigarettes per week. And if he or she don't smoke, then the value is 0. So I will add this new additional interval independent variable to the linear model. So I will repeat analyze regression linear, and after that we'll move, if yes, how many cigarettes per week. We'll move here to the field independent variable. But now I will press the button statistics, and here I will check these options. This option is tau. Tau is coefficient of tolerance or just tolerance, and then continue, and then OK. These coefficients of tolerance are important because they show interaction or interactions between factors. This coefficient of tolerance is in fact a coefficient of indetermination, but first dependent variable, in our case this is optimism, the dependent variable is removed from the model, and the one of independent variables becomes dependent. And this tolerance measures percentage of the variance of this particular independent variable, which are not explained by the other independent variables. So in our case, 100% of the variance of H are not explained by the number of cigarettes per week. And of course, also 100% of the variance of number of cigarettes per week are not explained by the age. Here we could use 50% as threshold. So if this tolerance is larger than 50%, that means that more than half of the variance of this particular independent variable is not explained by the other independent variables. So here in our case, both coefficients are larger than 50%. So these two independent variables are independent. There is no interaction between them. And this is excellent. This is very good situation. But it is possible to have interactions between independent variables, and then, like in previous topic, we must remove some of independent variables, and we start with this independent variable with the lowest value of tolerance. If there are coefficients of tolerance smaller than 50%, then we remove the first factor, the first independent variable with the lowest tolerance, and check again for the interactions between factors. If there are interactions, then we remove the next independent variable, again this one with the lowest tolerance, and so on and so on, until all remaining independent variables are with tolerance above 50%. So in our case, both independent variables are independent between themselves. There are no interactions between independent variables. And now, next step is to make interpretation of the coefficients. So I will write new model. The model with one independent variables. Independent variable was this. Now with the second, A becomes 1922. H, I will write here H and plus, sorry, not plus, minus 0.1 cigarettes per day. This is the second independent variable. So before the break, I said that if H increases with 1 year, then optimism will increase with 0.07 scores. Here, I can say that if H increases with 1 year, then optimism will increase with 0.08 scores, but I must add under condition that all other factors in our model are constant, or I must add under the same conditions. So if age increases with 1 year, then optimism will increase with 0.08 scores under condition that number of cigarettes per day is constant. And if number of cigarettes per day increases with one cigarette, then optimism will decrease with 0.1 score under condition that age is constant. So to the previous interpretation of this model with only one factor, we must add under the same condition or must add under a condition that all other factors in the model are constant. This is the first. Second, when we have more than one independent variables in the model, we can order them according to their importance. So here we can have so-called importance to model or predictor importance. And for this importance to model, we use so-called standardized coefficients or beta coefficients. And here you can see a standardized coefficients. For age, coefficient is 0.22. For a number of cigarettes per day, per week, cigarettes per week. Here. For number of cigarettes per week, the standardized coefficient is minus 0.07. But when we compare these standardized coefficients, we compare the absolute value. So the sign doesn't matter. It doesn't matter whether the sign is plus or minus, or it doesn't matter whether this coefficient is positive or negative. We compare them or we order them by their absolute value. And since here 0.22 is more than 0.07, then we can say that age is more important than number of cigarettes per day, and more important for the optimism, for the dependent variable. So the most important factor here is age, and number of cigarettes per week is a less important factor. And after that, I forgot to see significance level, but significance levels for both factors show that for the factor age, significance level is smaller than 5%. So there is a relation between age and optimism. But for the factor cigarettes per week, significance level is 16%, which is larger than 5%. So there is not a relation between number of cigarettes per week and optimism. And after that, we can calculate or we can compute the measures of strength of relation. We can compute coefficient of correlation and of course a coefficient of determination. Here coefficient of correlation R is 0.23, but here when the independent variables are more than one, this coefficient of correlation is multiple coefficient of correlation. That means that it measures the strength of correlation between the dependent variable and all independent variables together. So coefficient of correlation is 0.03, 0.23, and coefficient of determination is 0.05 or 5%, and that means that 5% of the variance of optimism are explained by age and by numbers of cigarettes per week together. In SPSS, we can measure the strength of correlation, the strength of relation between dependent variable and each independent variable separately. But here in PSSP, this is not possible. So I will switch to the presentation, and I will show these measures of strength of relation between each of independent variable and dependent variable. Sorry. For that purpose, we must check here part and partial correlations, and we need these partial correlations. So here is the explanation of the tolerance, of the coefficients of tolerance. After that, this is model adequacy. After that, we have significance level of all factors, interpretation of all coefficients, then ordering or comparison of factors according to their importance, and this is multiple R square, and here here we have partial correlations, and since these coefficients are partial coefficients, that means again that when we make interpretation of them, this interpretation is under the same conditions or under the condition that all other factors in our model are constant. So the correlation between age and optimism is 0.22 under condition that number of cigarettes per week is constant. And also the correlation between number of cigarettes per week and optimism is minus 0.08 under condition that age is constant. So this is the interpretation of these coefficients. And now again in SPSS we can make multiple non-linear regression. As before the break, we made non-linear regression with single factor. Now we can make non-linear regression with many factors, but it is possible only in SPSS. In PSPP, such analysis is not possible. To perform multiple non-linear regression, first we choose dependent variable, in our case optimism. After that, we must define parameters of the model, and each parameter is defined by its name and by its starting value. We define the number of parameters depends of chosen model. Some models have more parameters, some models have less parameters, and the chosen models, the chosen model define the number of these parameters. After that, we must write the equation. We must write the formula here, and then the model is ready. So in this example, again, dependent variable is optimism. Again, two independent variables are age and number of cigarettes per week. But model here is exponential model. And these are coefficients of exponential model. Here we have not a significance level. And since we have not significance level, to define significance of these coefficients, we can use so-called confidence intervals. So if 0 is inside the interval, then we must accept the null hypothesis, and this means that there is no relation between this factor and the result. And opposite, if 0 is outside the interval, then there is relation between this particular factor and the dependent variable. Here, in our case, for the age, for the first factor, 0 is outside the confidence interval. That means that we must accept alternative hypothesis, or means that this coefficient is statistically significant, or means that there is a relation between age and optimism. And for the second factor, for the number of cigarettes per day, the 0 is inside the interval. That means that we must accept null hypothesis, and that means that this coefficient is not statistically significant, or that means that there is no relationship between number of cigarettes per week and optimism. And our interpretation here is according to the exponential model. Here we put exponential model in this cell when the change of independent variable is absolute, and the change of dependent variable is relative. So the first coefficient shows that if age increases with 1 year, then optimism will increase with 0.4%. And again, under condition that the number of cigarettes per week is constant. And for the second factor, for the second coefficient, if the number of cigarettes per day increases with one cigarette, then optimism will increase with 0%, and again under condition that the age is constant. And last is here multiple correlation. And in this case, this is not multiple correlation, this is multiple determination, because it's R square, and R square shows that 5.5% of the variance of optimism are explained by age and number of cigarettes per week together. And this is so for the multiple regression models. Now, I will continue with correlation analysis. But before that, yesterday, in the introduction to relation analysis, I said, and not only I said, but we discussed together that if we want to analyze a relation between age and motivation, it is easy to say which variable is independent and which is dependent. It is easy to say that age is factor and motivation is result. But if we want to analyze the relation between motivation and satisfaction, it's not too easy. We don't know which variable is dependent and which is independent. And in such cases, we can use only correlation analysis, because until now, correlation coefficient and the coefficient of determination were part of regression analysis. Correlation analysis was part of regression analysis. But we can perform correlation analysis without regression analysis. And when we don't know which variable is dependent and which is independent, then the better way is to use only correlation analysis. And now I will switch again to PSPP. Here we have analyze bivariate correlation, and I can put all these interval variables together. So H, I will move H from left to the right. Number of cigarettes per day, per week also, and optimism also. And I can check this checkbox here, flag significant correlation. After that, press OK. And let's see the result. So here we have correlation coefficients pairwise. The first pair is age and number of cigarettes per day, per week. The second pair is age and optimism. And the third pair is number of cigarettes per week and optimism. This table is called correlation matrix. And here, the coefficients, the number is 1. Here is 1, here is 1, and here is also 1 because this is correlations between each factor itself. Age with age, normally 1, number of cigarettes per week with number of cigarettes per week. Again, normally the correlation is 1, and optimism, normally correlation is 1. And these values here, these numbers here above, and these numbers here below are the same, because if we change places of both variables, the relation is the same. And if the relation is the same, then the coefficient, two coefficients will be equal. So you can see here 0 minus 0.012, the same here, 0.201, the same here, and minus 0.076, the same here. But only one of these coefficients is statistically significant, and this coefficient is flagged with A. You can see here A, and a footnote A significant at 5% significance level. So only the relation between age and optimism is statistically significant. Two other relations between age and number of cigarettes per week, and between number of cigarettes per week and optimism, are not statistically significant. So in SPSS, we have an additional option which is very useful, because here in bivariate correlation, we can choose not only Pearson correlation, like is in PSPP. In PSPP here is written Pearson correlation, but here instead Pearson correlation, we have also Kendall's correlation and Spearman correlation. These two coefficients, coefficient of Kendall and coefficient of Spearman, are called coefficients of rank correlation. And they are useful because when the Pearson correlation is computed, it is assumed that the model is linear. But when Kendall and Spearman coefficients are computed, no model is assumed. So that means that if Pearson correlation is statistically significant, then there is linear relation, linear model between two variables. But if Pearson correlation is not significant and Kendall and Spearman coefficients are significant, then there is a relation between these two variables, but this relation is not linear. And of course, if all three coefficients are not significant, then there is no relation between these two variables. So let's compare the results. We already saw these results for Pearson correlation. Only correlation between age and optimism is significant. But when we compute Kendall and Spearman coefficients, then the picture is different. First, about the relation between age and optimism, you can see that all three coefficients are statistically significant. That means that this relation is linear. But for the relation between age and number of cigarettes per day, you can see that Pearson correlation is not significant, but both Kendall and Spearman coefficients are significant. That means that there is a relation between age and number of cigarettes per week, but this relation is not linear. And the last, for the relation between number of cigarettes per week and optimism, all three coefficients are not significant. That means that there is no relation between number of cigarettes per week and optimism. So this was the end of this topic about the analysis of relation between interval variables. Questions?
Oh, thanks.
Okay.
Sorry, I have one question regarding hierarchy multiple regressions.
Okay.
It's if let's say we are running a test to see whether the big five personality traits have an effect on job satisfaction. Can we put all five of them simultaneously within a model, or do we have to run multiple regressions?
For me, the better approach is to use multiple regression, but in practice, very often researchers make a set of simple models. So one approach is to use five different models with only one independent variable in each model. And other approach, the second approach, is to use multiple regression. For me, the approach with multiple regression is better because this approach allows us to check, to test interactions between factors. And I will return previous presentation here.
That's what I was thinking because I can check the individual variance of each personality trait and how it relates to the job satisfaction.
Just a second. Here. This presentation. And these two examples for indirect impact and third reason, if there are possible misleading results, the better approach is to use multiple regression because separate models with only one independent variable will not show the interaction between factors, and interaction or interactions between factors is or are very important for the interpretation after that of results. So I will recommend one multiple regression model, but I know that in practice very often the approach is different. Approach with many models with one single factor.
Okay, thank you.
Okay. Other questions? Okay, I will stop recording.